Hello, ladies and gentlemen. Today we are going to review a bunch of right triangle skills. So the purpose of this video is just sort of review all of the right triangle ideas that we learned before. And those are the basic tools that we have whenever we're working with right triangles, okay? So in your notes somewhere, I want you to make a list. This list is the same list that would be up in the classroom when we're talking about right triangles. What are the ways that we can solve for missing pieces in right triangles or missing sides? Well, the first way we can maybe use is the Pythagorean theorem. If you remember that one, that's a squared plus b squared equals c squared. And remember, c is always the hypotenuse or the longest side in the right triangle. Or if we have a 45, 45, 90 triangle, these are the degrees that we see in the triangle, then we can go ahead and use a shortcut to help us figure out missing sides. And the shortcut for this is that the hypotenuse equals the leg times the square root of 2. So if I know a leg, I can real quick figure out what the hypotenuse is just by plugging it in right here, and I don't have to go through the Pythagorean theorem to figure it out. Now, when we talk about 30, 60, 90 triangles, we had two shortcuts for that. We had the long leg equals the short leg times the square root of 3. And we also had that the hypotenuse equals 2 times the short leg. So these two formulas help us figure out missing sides when I notice I have a 30, 60, 90 triangle. Now, if Pythagorean theorem doesn't have enough information, or it's not a 45, 45, 90, or a 30, 60, 90, then I need to have another option, and that's where SOHCAHTOA came in. Now, remember, this is trigonometry. Trig! So remember that the sine, the sin button, is the opposite over the hypotenuse. And the cosine, the cos, is the adjacent over the hypotenuse. And the tangent, ooh, this is getting a little messy, is the opposite over the adjacent. Okay, that's what those all stand for, and those are all in your notes already. So these are the basic tools we have whenever we're using or see right triangles. We know that we can use one of these tools. So let's use one of those tools to solve this guy for x. So notice I have two sides and I'm missing a third. This is a perfect opportunity for Pythagorean theorem. I can't use the fact that this is a 45, 45, 90 or a 30, 60, 90 because I don't have the 30 and the 60 marked in my triangle. So I can't assume. I need to just use the Pythagorean theorem for this guy. So a squared plus b squared equals c squared. A would be 6. B is an x, and c, the hypotenuse, is a 15. So 6 squared, 36, x squared, 15 squared, 225. So if I have x squared equals that, I would take 225, take away 36, right? Figure out what's left. I have a 189. And then if I go ahead and square root 189, I get myself a decimal, which sometimes happens. You can have 13.7. If I want to break apart the square root of 189, that's where we divided out perfect squares. And this guy divides out into 9 and 21, which is 3 square roots of 21, because the square root of 9 turns into a 3, and the square root of 21 is just a weird decimal, so we leave it. This is the exact value. When it says exact, that means I'm not allowed to write a decimal. This is an approximate value because, as you know, when you type this in your calculator, there's a lot more decimal values after this, and even if at the end of the screen, the calculator rounded a little bit. So that's one tool we can use is Pythagorean theorem. Another tool we can use is special right triangles, and that's one of these guys, right? Look at him. He's a 45-degree angle. Anytime I see a 45, a 60, or a 30, I'm going to use one of my shortcuts. So if this is a 45, 45, 90, I'm going to use the shortcut. The hypotenuse equals the leg times the square root of 2. The hypotenuse is marked with x, so I'm going to plug it in. The leg is marked with an 8. And then 8 dot square root of 2 just means 8 square roots of 2. So x equals 8 square roots of 2. See how fast that was to find the exact value? I don't have to have a calculator. I don't have to get a decimal. I can leave it as an exact as long as I know my shortcuts. And here's another one where I see a 60-degree angle. So again, 30, 60, 90 shortcut will apply here. So a 30, 60, 90 shortcuts, there's two of them. we have the hypotenuse equals 2 times the short, and the long leg equals the short times the square root of 3. So look at this beautiful triangle that we're given. We're given this, the 6, the hypotenuse. So I need to start with this formula because it has the word hypotenuse in it. So 6 equals 2 times the short leg. What's the short leg marked here? X, right? So x is going right there, and I would just divide by 2 to get the x alone, so I can solve for x. 6 divided by 2 is 3. So x would just equal 3. Now, it doesn't say I have to solve for y in this example, but if I wanted to, I could just put that into my other formula, and the long leg, or the y, would equal the short leg, which is 3, times the square root of 3, and then so y would equal 3 square roots of 3. Done. So my shortcuts, make sure we know when we can use them. When I see a 30, a 60, or a 45, that means I'm definitely going to use one of my shortcuts. Now, if I can't use Pythagorean theorem and I can't use one of the shortcuts, then what options do I have? SOHCAHTOA. So this is a situation where that happens. I see a 35-degree angle, but there is no shortcut for 35-degree triangles. So instead, I'm going to use some SOHCAHTOA formulas to help us figure it out. So writing SOHCAHTOA here. So if I'm standing at the 35-degree angle, remember SOHCAHTOA is always set up from an acute angle. If you are standing at the 35-degree angle, this side right here would be opposite you. And this side, 20, would be adjacent to you or next to you. The side I don't know anything about over here is the hypotenuse. I don't know anything about him, so I can't set up any of the formulas that have the word hypotenuse in it. So sine, opposite over hypotenuse, can't do that one. Cosine, adjacent over hypotenuse, can't do that one. Tangent's the one that has opposite and adjacent in it, and those are the two pieces of information I have labeled on my picture. So I'm going to set up the tangent formula. And it goes like this. The tangent of the angle you're standing at, which is 35 degrees, equals opposite, he's labeled with a little a, over adjacent, 20. And now this is where we go, and we, to solve, are always going to cross multiply. So put this guy over 1. Cross multiply 1 times a is just a. And then here, if I cross multiply this way, I get the tangent of 35, which is a gross decimal in your calculator, times 20. So go ahead and type in the tangent of 35. Make sure you put parentheses and shut the parentheses after the 35 if your calculator brings them up. You gotta shut them. Shut the 35 and then take it times 20. You're going to get a decimal because remember the tangent of 35 is a decimal, but it's not terrible. It's like 14 point, in this case, it's 14.00, so that's pretty good. That's pretty much straight on, except a little bit, you know, there's a little extra left over there with a 0.004. But this is the approximate value for this missing side using our tool of SOHCAHTOA. Okay, so that sums up our right triangle tools. I want to thank you for taking good notes today. Kincaid out.